Okay, this is Jim Ledoux, and we're going to go through a debrief of the warning stage. This is warning stage doesn't mean you're issuing a warning; it means you're considering whether or not to issue one, and then you do after that make a decision. But the key thing here is that we're looking at the debrief for the analyzing and forecasting component. So it's much like what we did before with the short-term forecasting component, but now we're going to go ahead and look with a much shorter lead time. The mesoanalysis of snow squalls, and then, of course, looking at snow squall conditions. So we'll do that, and then this is after that you get set free to go ahead and do this cycle. What is this cycle? Again, it is this. You're checking the environment, precip forcing mechanism, snow squall environment. You do that roughly hourly, and then after that, you're tracking the winter hazards themselves. So that's literally part of the continuous cycle. So we'll start off with the hourly, and then we'll actually go ahead and take a look at the initial winter hazards before you get set off. So this is essentially what we're going to do. We're going to perform this mesoanalysis short-term cycle, look at the snow squall, and I'm going to go ahead and analyze potential hazards. And then after that, we'll take a look and do a forecast. This is just looking at observed data, and then we'll take a look at the band location and potential intensity over the next 2 hours. So that's what we're going to do. Let's go ahead and jump right in. Look at the precip forcing mechanisms to start off with. And I set the same procedure. This is the winter precip forcing for the RAP 13 version 2, same one as we used before, but this time I time matched to the actual satellite imagery, so we're getting 5-minute updates roughly. So the RAP 13 is going to look frozen here as we step back and forth. The key thing, though, is that we have this frontal band in the GOES RBG. It's dropping to the south, and it's interesting that we're starting to see what looks like a difluent baroclinic leaf cloud starting to develop with ribbed patterns in other words, something like transverse bands going through, cross-cutting this divergent cloud signal. So that's an interesting thing in itself, as if there's a small-scale shortwave trough developing on the backside of the big wave that's curling up through the eastern Dakotas. The other thing of interest here is that a little bit further south and southwest of this, we have, again, if you look at the IR imagery here, very much so, a lot of cold top clouds. Again, this is post-frontal. It's a lot of deep moisture, at least, especially in the lowest 2 kilometers. So again, with this, it seems like we have shortwave forcing. We also have maybe not as well defined as before, but high trope pressures advecting towards roughly lower trope pressures. So there's overall a large synoptic field favorable for synoptic uplift, and especially in the upper troposphere. Lower troposphere. Now, this is one thing. We'll look at the warm advection signal and frontogenesis. The front that was earlier up in northeast Wyoming now has settled down into southeast Wyoming, angling northwest into somewhere east of Yellowstone. And we still have frontogenesis signals across this in spots, as well as what you see in the dashed white lines, um, favorably low equivalent potential vorticity. Okay, this is like a geostrophic equivalent potential vorticity. So it's indicative of at least slantwise instability at this point. So that is very favorable. The frontal signal is strong, it's still continuing, and has moved south closer to Cheyenne. Now, up here, let's say in the 600 to 700 millibar layer, we have the thermal advection, again, the same temperature field that we plotted here, 650 to 600 millibar temperature plus the winds. And we're still seeing that cold advection signal. This is not a warm advection event. It should be plainly obvious that's the case there. So overall, we still have frontal signal and a wave aloft. Not much of a signal for vertical motion in the warm advection because it's no warm advection, just cold advection. Now we go ahead and flip over to the snow squall parameters. This one, likewise, I time matched to the satellite imagery. In fact, I should do that right here. Okay, so now I time matched to the satellite imagery. You can see it rolling back and forth. And now we're going to go ahead and zoom in. Okay, I've loaded up the snow squall parameter procedure, SQ mesoparams, with RAP 13 as the basis for the data, and then time matched to the GO16 air mass RGB in the background. And I think this is what we expected here based on the earlier short-term forecast. The area of favorable snow squall parameters is coming down. The front is coming into the central and southern parts of the Cheyenne CWA, approaching Cheyenne and Laramie. And what we can see in the upper left panel, the 0 to 2 kilometer RH and winds are coming in. High RHs and the high winds are sweeping in right behind that front. The instability here and the theta E difference also shows low values coming in. The values are dropping with time into the southern parts of the CWA. Not quite as low as the negative values that we're seeing up here in northeast and eastern Wyoming. But those values are starting to sweep in too. And so, because of that, the snow squall parameter shows positive values here. You can see the blue dashed contours coming in and moving all the way into the southern part of the CWA. So right along and just behind the front, right along and also co-located with the maximum in pressure rises and with the pressure gradient, the isobaric pressure gradient just on the south flank. So all of that is approaching Cheyenne. At the same time, we have strong frontogenesis signals showing up and also sweeping in. So everything is pretty much on target for favorable snow squall parameters and initiation to continue on in. Now let's go ahead and take a look at the hazards analysis. We could actually use this for our WarnGen display if we wanted to, and certainly would be legitimate to do it because it has all the hazards that we need to know about when we're concerning snow squalls. I got the wind observations plotted by METAR and also the HRRR analysis, the latest HRRR analysis up here on the left, upper left that is. We got the visibility plot either by METAR or by HRRR visibility analysis. They got the MRMS, lowest altitude reflectivity here in the lower right, and then the satellite imagery in the lower left. At dark, it's going to be the IR imagery. And at this point, the conditions are rather subtle here in terms of what is likely precipitating clouds, since the cloud tops are rather subtle, where we don't have much differentiation between that cloud top temperature that is not precipitating and that it is. But in this case here, it looks like this leading edge is precipitating here and is just right next to Cheyenne. So we're at 0330Z. And hazards show up pretty clearly if I zoom in onto this area. Okay, the HRRR's showing widespread areas of gust of 40. I think it's going along that it's a little bit higher than what I'm seeing in the observations. Here again is Cheyenne. The front has not passed through yet. The front is just north, along and just north here. It's not quite going to that point where I'm seeing gusts of 40, but I'm seeing upper 30. Here's a 32 just across the border where it's actually raining at this time. Smaller observations that you see, I'm going to go ahead and magnify it, represent all the other plots that we have available, not METARs, but Wyoming DOT site, for example. There's a YDOT site gusting roughly almost to 30. Here's another one gusting to 26. And notice this one here has a low visibility as well. In fact, we're in the precipitation. This is far north in Laramie County. And this site is a DOT site on I-25. Pretty much lock stop right where the HRRR is showing low visibility. And this YDOT site has a visibility sensor of 0.42, so 0.42 miles. If you haven't checked the YDOT sites, they are there. They give you visibility observations, and that's something that's quite useful in this case because 0.42, less than 0.5 miles, certainly is conceivable to have visibilities down to a quarter mile, especially if you go on up a little bit farther north. This site only has 1.24 miles, but there may be places where it's been snowing for a while, the temperature's well below freezing, and we'll wind up with some blowing snow. So certainly road temperatures will be dropping fast in this region up here. Leading edge of the band, according to the MRMS Rolla, is pretty darn close uh, to Cheyenne. It's a little bit north of Cheyenne, about 10, 15 miles up here on I-25. A little bit closer to the east, but to the east, the temperatures are fairly warm. This site is not warm. You go a little bit further east and it warms up even more. Again, back in Banner County, Nebraska, we have rain, light rain. So that extends into Wyoming a little bit. Maybe not too far since Banner's already, the Banner County ob is already at 33 degrees. That's what's happening at this point. The motion of this band is coming to the south, and it's coming to the south fairly quickly. So at this point here, I would imagine that within the hour it's going to be inside of Cheyenne. There's 03, let's see, 0246, 0252, and now we're at 0306, and you can see that it's moving in quickly, but it's also pivoting a little bit more northeast or northwest to southeast. So it might be helping slow down its arrival time just a hair, but that's what we see. I think in this area here, we're seeing the winds, we're seeing the visibilities. For example, here that this is really approaching what would be considered snow squall criteria. Okay, there was some question about whether you can tell if there's a melting band or a bright band in radar. And so that might help you actually discriminate more precisely where the rain snow line is. So we have the half-degree angle here. We're looking at the Cheyenne radar. We remember before looking at the soundings and then the surface temperatures, the temperature, the max temperature, and including the max wet bulb, was mainly above freezing at the lowest levels, with the maximum temperature or wet bulb at shelter temperature level. So we go with that play, and we see these temperatures above the melting point around Cheyenne, and then extending off to the east. According to the left half degree, we have a melting level of about 7,500 MSL. That's only about 2,000 feet above the ground, straight east on I-80. And surface obs had rain in far western Banner County in Nebraska, down and then down south. So I suspect when you're looking at this area here, and based on all the observations that we've seen, this is all snow, and it's reaching the ground as snow. And in fact, the temperatures are probably falling below freezing almost immediately behind the onset of this heavier precip. So I think it's pretty much fair to say that the hydro class, that being all snow, is pretty accurate at radar beam height. But we do know that below radar beam height over here in western Nebraska, there's probably a little bit of rain mixed with snow, at least for now. So to review here, our hazards analysis, we have frozen freezing precipitation just north of Cheyenne, extending off to the south. This is roughly at 03Z, and since between 03 and 0330Z, it's kind of extended down a little bit just to the east side of Cheyenne. But nevertheless, we do have visibilities less than half a mile. Wind gusts are in excess of 40 miles an hour across a broad region, especially now post-frontally. And a little bit of rain over here, extending a little bit into Wyoming's state, but not as far as I-25. Visibility is being less than half a mile, actually reported by WYDOT. This says to me that we have a snow squall at hand here. Question is whether we issue a warning or an SPS.